All right, so we are now at the end. We are at the final stretch for our review. This is going to be questions number 31 through 45 in our calculator active section for the EOG review. Remember, make sure you are only watching one of these each day. They are really long. It's a lot of information. And make sure you're quizzing yourself, not if you know the answer, but quiz yourself if you remember what steps you were supposed to take to solve each problem along the way. So for number 31, which expression is equivalent to 8 plus 2 parentheses 3a plus minus 5? So what we're going to do is start with distributive property. So carry down the 8, but we did do 2 times 3a, which is now 6a, and 2 times minus 5, which is now minus 10. We then can go ahead and combine our 8 and our minus 10. Now, positive 8 minus 10, if I do that, will come out to be negative 2. All right, so we have 6a minus 2, and that's where we're going to leave this problem for number 31, is just 6a minus 2. For number 32, we have on a Saturday, 40% of visitors at an art museum were students. If 140 students visited the museum, what was the total number of visitors that day? So we've got 40% of visitors were students. So let's set up our part over total equals percent over 100. So our 40% goes over 100, and the 140 students goes up here. That is our part for this equation. Then we just solve like we normally would. We'll cross multiply for 140 times 100, and then we will divide that by 40. So 140 times 100 gives you 14,000. 14,000 divided by 40 gives me an answer of 350, which is our answer for number 32. For number 33, it says Leonard runs a pet sitting service. He charges $20 per day, which includes 3 walks and 2 feedings, and then he charges $5 for each additional walk. Which expression describes how much Leonard would make if he charged for a single day of pet sitting? All right, so for this one, we don't really need the per day part, seeing as we're just asking about one single day. So for one day, it'll cost $20. And then $5 for each walk. So normally, if it's 2 walks, we would do 5 times 2. 3 walks, 5 times 3. But in this case, we don't know how many walks. They just tell us W walks. So we're going to do 5 times W. And we'll be looking for our equation C for this. We'll be looking for 20 plus 5W. Moving on to number 34. For this problem, we have a hexagon, and unfortunately, it's not like the hexagon from the first practice test we've done. But see, the first practice test, our regular hexagon would involve breaking this up into 6 identical triangles. Now, unfortunately for us, that won't really work, because for this, I've already gone through and tried, the area of each triangle will not have those 2 areas. I'll show you. The base of each triangle would be 52 millimeters, and the height of each triangle would be, well, half of 90, which is 45. So if I were to do 52 times 45 and then divide it by 2, well, let's see. Times 45, so 2,340, divided by, let's see, that would be divided by 2. There we go. That gives me 1,170. But if we look at C, it says each triangle has an area of 1,352. So no, that's not correct. That is not going to be the area of my triangles for this one. So C and D are out. So instead, what they suggest is that you could decompose the figure into a rectangle and 2 triangles. Now, if I were to do this, I could simply cut it this way. And I could cut it so that my rectangle has a height of 52 and has a base of 90. Well, we can solve that pretty easily. 52 times 90. And that does give me 4,680, which is the same for both A and B. So unfortunately, this means we do have to find the area of my triangles. So if I were to find the area of my triangles, we already know the base of one of the triangles right here is 90. And the height, we don't know the height, but what we do know is the height of the whole entire shape is 104. And we know this middle section right here is 52. So for starters, we can do 104 minus 52 to figure out what is the height of both triangles combined. So we've got 104 minus 52, which is 52. And then there are two sections like that, this one up here and this one down here. So we will actually do 52 divided by 2. That 26 is what we will use as the height for our shapes. So then we just punch in our equation. Area of a triangle is base times height divided by 2. So the base times the height times 26. So that's 2,340 divided by 2 gives me 1,170, which matches my answer for option B, not A. So for number 34, it's a lot of work for this one geometry problem, but it will be B. For number 35, it shows a graph right here with amount of money raised for the y-axis, number of cars washed for the x-axis. And it's asking us which of these tables down below match this graph. So let's just look at a couple of coordinates. If I wash 5 cars, it looks like I'll be making $25. So let's see. So 5 cars washed, $25. That works. 25 cars washed, $5. No, that's not correct. C, it says 5 cars washed, $25. D says 25 cars washed, $5. No. So B and D are out. We're done with those. Let's keep looking between A and C then. If we wash, let's say, 10 cars, that will match up to $50. So 10 cars, $50. 10 cars, $30. No. So C is out. A is the only one that has multiple coordinates that are matching what they say in our graph. So 35, we got A. For 36, this one is finding volume of a prism. So all we have to do is, for volume, we're doing length times width times height. And this is a good chance to practice using this calculator, desmos.com/scientific, that you'll be able to use during the EOG. So first, we're going to do 6 1/2. So 6, click the fraction button, and 1/2. Click out of the fraction, because we're done with it, times 3 inches, times, and we've got 4 1/2. There we go. 6 1/2 times 3 times 4 1/2 gives me 87.75. Now this, just look at the whole number. There is only one answer choice that also has 87 as the whole number, and that is generally how it's going to work out for the EOG. They're not going to have multiple 87s with different fractions to try to throw you off. For number 37, it is asking for a ratio for the number of textbooks to the total weight. So this one, it's tempting to use because it's the first ratio we see, but because those have decimals, because they are not whole numbers, it makes it tricky. Look at a different section that has whole numbers. Number of textbooks, 12. Total weight, 42. Simplify these numbers instead. They are both whole numbers, they are both even. It's pretty easy to start simplifying. For example, both 12 and 42 are divisible by 2. 12 divided by 2 is 6, and 42 divided by 2 would be 21. Now, it's still not an answer choice, but you could go farther. See, 6 and 21 are both divisible by 3. So you could also do 6 divided by 3 to get 2, and 21 divided by 3 to get 7, which reveals our answer to be C, which is 2 to 7. For 38, Kendra spent 1 and 7/12 hours making and eating dinner. Okay, she spent 3/4 of that hour making dinner, which correctly shows how to find the amount of time she spent eating dinner. Okay, so we have a total. The grand total for making plus eating, and that gave me the total, which is 1 hour 7/12. Okay, that is how much time. So make plus eat equals 1 and 7/12. Now, we do know how much time she spent making dinner. So we know it is 3/4 of an hour to make dinner plus an amount of time to eat dinner equals 1 and 7/12. Well, let's see if we can find an equation like that. It looks like A matches that pretty well. They did mix things up. They moved the amount of time for eating to the front, but it's the same. It is going to be D for how much time she spent eating dinner plus the amount of time she spent making dinner will give me my total. That is what we were looking for. If you were looking for 1 and 7/12 minus 3/4, that would also give you the right answer, but it's not an answer choice. Also, if you chose D because you knew the answer was 5/6 but didn't read the equation, now you understand why you might have gotten it wrong. For number 39, a long problem took up 2 pages in the book. This one is asking which trapezoid is represented by these coordinates. So first, let's just pick one coordinate and try to find it. A is at -3, +2. So let's see which of these graphs is at -3, so we go 3 to the left, +2, so we will go 2 up. So -3, +2 should be right here, and it's not. A is out. For B, -3, +2, that checks out. That is where A should be. For C, -3, +2, nope, there is nothing there. And for D, -3, +2, nope, there is nothing there either. So while C was kind of close, B is the only one that has the coordinates in the correct page, or in the correct section. So that's going to be number 39. For number 40, if P and Q are both integers, what statement about P minus Q is true? So this is saying they are both integers. So what I like to do for these problems is I like to set them equal to 1. Just 1. And then, theoretically, 1 minus 1. Okay, let's go through the rest of these problems and see what happens. If both, whoops, hit the button one too many times. If both P and Q are negative, okay, so this would be -1 minus -1, okay? If they are both negative, then P minus Q will always be a negative. Well, no, not necessarily. See, in this case, if I have a double negative, you guys have seen this happen, where I've had -1 and it equals a +1. This is the same as saying -1 plus 1. Well, think about it. If I have a +1 and a -1 and I try to combine them, well, that's going to equal 0. That's not going to equal a negative integer at all. So, right off the bat, A is false. That doesn't always happen. If P is negative, okay, so -1, and Q is positive, -1. So, +1. It will always be negative. Well, in this case, it certainly does seem to be true. -1 minus 1. This is saying that on a number line, I'm starting at -1. And if I'm doing -1, I'm going to move down on my number line. So that does make sense. If I'm at -1 and I go down by 1, I'm now at -2. I did make the number negative. So far, B is holding true, but let's see what happens with the rest of our problems, or the rest of our answer choices. C says if both P and Q are positive, okay, so 1 minus 1, then P minus Q will always be positive. No. 1 minus 1 is 0, which is neither positive or negative, so already C does not work. C is out. D says if P is positive, okay, so positive 1, and Q is negative, okay, so minus -1, then P minus Q will always be negative. No. We talked about this a moment ago. Double negatives become positives. So 1 plus 1 is most certainly not negative. It is definitely positive 2. So C and D being out, B was the only one that held up simply to replacing with positive or -1. That's all we had to do to check for number 40. And that's all you really have to do as well. For number 41, this one's a bit tricky because it doesn't really work as well as some of the other statistical problems. It's saying that 2 more scores will be added to this plot, and it's asking what value for both of these scores could I add to make this data more symmetrical. What they mean by that is they want everything to come out balanced. They want everything to be perfectly balanced. Think of Thanos and the Infinity Blade. Everything has to be perfectly balanced. So, almost dropped my phone. So, for this problem, here is kind of the middle of all of that. You can kind of see, like looking at all of this, 80 was kind of in the middle. And we're trying to see where could we add 2 x's to make this more symmetrical. Option A says 95. No, that does not make things more balanced. That tips things over to the right side, so it's not going to be A. For B, 85. Well, 85 would be here. Again, no, it's still tilting things too far to the right. So, no, it's not going to be B. 75 is close, but I wouldn't say this made things perfectly balanced. It just kind of made the middle part wider, because now the middle is both 80 and 75. But it didn't really make it more symmetrical and more even. Now 65. If I had 2 x's over here, that balances out well with the 95s that were on the other side. And now things are somewhat more balanced. Still not perfect, but it's more symmetrical than it was before. So for 41, we were looking for 65 as our answer. Number 42, this was not meant to trick you guys, but for some reason, some of you are still convinced that this is not one full section, but it is. Okay? All we need is the base times the height. So, 1, 2, 3, 4, 5 units is the base. And for the height, 1, 2, 3, 4 units for the height. 4 times 5, 20. This is a parallelogram. The area of a parallelogram is just base times height. There is no divided by 2. You only divide by 2 if it is a triangle and only a triangle. This is a parallelogram. This is not meant to be solved as 2 separate triangles. For number 43, Mrs. Trainer wrote an inequality on the board. It says x is greater than or equal to 10. What best describes the solution to the inequality? A says the only solution is 10. No, that is fundamentally not true. If 10 was the only answer, we would have used an equal sign, not an inequality. The solution is any number. No. I think you all would agree that if I put 5 in there, this would not work. 5 is definitely not greater than or equal to 10. So B is out. C says the solution is any number 10 or greater. And that does work, because x could equal 10. X is greater than or equal to 10. But it could also be any number more than 10. It could be 11, it could be 100, it could be a billion. But it doesn't have to just be 10, so C works. D says it is any number less than 10. No, it is definitely nothing less than 10. So, moving on to number 44, the final two problems. Number 44, the combination of a safe has three numbers. The first number is the greatest common factor of 16 and 40. So 16 and 40, we are breaking this down to all the numbers that we can divide these two things by. So starting with 16, I can divide 16 by 1 and 16. I can divide it by 2 to get 8, and I can divide 16 by 4, and that's it. For 40, I can divide 40 by 1 and 40. I can divide it by 2 to get 20. I can divide it by 4 to get 10. And I could divide it by 5 to get 20. Whoop, not 20. I can divide it by 5 to get 80, or 8. So the biggest number they have in common is 8. So my first number should be 8. So far, it's either going to be C or D. A and B are eliminated. Yes, you could divide 16 and 40 by 2, but that's not the greatest factor they have in common. Same thing for 4. You could divide them by 4, but you can both divide them both by 8 instead, which is larger. Alright, the next two options that we're trying to find will be between the greatest common factor of 25 and 75. So think about quarters for this one. You don't really have to draw the chart. 25 divided by 25. That works. 75 divided by 25. That works as well. 75 cents divided by 3 quarters. That's 1 quarter is 25 cents each. So yes, I could divide 25 and 75 by 25. Again, 5 does work, just like the last couple problems, but it's not the largest number that I could divide them by. So C was close, but it didn't work. And last but not least, for number 45, we are trying to find the missing part of this table. So we can see it almost looked like we were counting by 4 at a time, but I'm letting you know right now the answer should not have been 16. If you did this simply by counting, it didn't work so well. What you had to do instead was look at the relationship between one number to the next. For 6 to 12, we multiplied by 2. For 6 to 18, we multiplied by 3. For 6 to 30, we multiplied by 5. And then look at these. If I repeat that process, 6 times 2 was 12, 4 times 2 was 8. 6 times 3 was 18, 4 times 3 was 12. What you're really doing for this is you are simply repeating what is being done to the other side. So when I do 6 times 5 to get 30, I have to do 4 times 5 to get 20. That's what was happening with number 45. Don't just assume because you can see a pattern that that pattern is going to continue. Double check it using either multiplication or division whenever you see these ratio tables. You can't assume that these patterns are going to continue past the end of the problem. And that is going to be it for this review. This one is actually the shortest one. And part of that is a lot of these questions are very much helped by the fact that we have access to this calculator. And I'm just going to repeat, if you don't know the name of this calculator, there it is. Go to this website so that way you can get some practice in with this type of calculator. This is the one that's been on Canvas that we've been using for a long, long time. And that's really going to be beneficial to you. Just as a reminder, you are not supposed to do more than one of these videos per day. This is a lot of information. Only watch once per day, and just go through and watch one each day right up until the EOG. Make sure you're quizzing yourself if you remember how to solve a problem, not just if you got the correct answer. And that's going to be it. Good luck.